Alright, here's a riddle for you. I am sitting at a table. 10 flies are on the table. With one swat, I kill 3 flies. How many flies are left on the table? Without looking at the answer, I'm guessing that the answer is 10 flies. So if I'm wrong, I'll get back to you in the next video. Anyway, I hope you're doing well. Here we are in Chapter 9. And 9.1, we're still going to be dealing with a little bit of trig. But Chapter 9 is we're going to be dealing with over the next few weeks. It's kind of like a hodgepodge of different concepts: polar, vectors, parametric, and some other stuff as well before we finally get into some calculus. And anyway, today and tomorrow are all about polar coordinates, again, a concept that we use in AP Calculus, so the sooner you get it, like right now, the better. And then again, you'll see it in AP Calc. Anyway, over the period of time that you've been alive, you've been graphing points using coordinates in the XY plane, and for the first time you'll be graphing points in a polar coordinate plane. So hopefully you've printed out these notes, and you can see down here you've got these concentric circles, and I'm going to talk about that right now. So in an XY coordinate plane, you're given a set of coordinates, let's say 3, 1. It's an ordered pair, and so 3, 1 means you're going to go to the right 3 and up 1, and you'll plot a point. Well, that same point will have polar coordinates as well, but anyway, we'll get into how to do that. In the XY coordinate plane, your ordered pair would be X first and Y second. In the polar coordinate plane, you get an R first, and then you get a theta. Okay, so I'll describe what that means. In the R theta, we have, or I should say, in the polar coordinate plane, we have what we call a pole, and then we have what we call a polar axis. So the pole is just a dot right in the middle. In fact, the pole corresponds to the origin in the XY plane. So you can take the polar plane and put it right on top of the XY plane. You have them both. So we have a pole, and then again what we have is called a polar axis. We always need a reference point or some sort of a reference in which to start from. And polar, by the way, polar coordinates can be used in navigation, and when we get to class I will hopefully be able to show you a video of where you'd see a polar coordinate plane. You may have seen, like, you see a movie and you see something like this submarine. They can see some other submarine approaching it. You see this usually a line going around and around the circle, and you see these dots every time the line goes around and hits the dot might be getting closer and closer. So you may have seen that in a movie. Well, it's like that's a polar coordinate plane right there, where you have all these circles and you have basically an angle and a distance, and that's what we're going to describe right now. So anyway, you have an R and a theta, and let's just say we use the R as 3, and the theta, let's say, is pi over 6. Okay, 3 pi over 6. That means that there's a point right out here at an angle of pi over 6. Now we know where an angle of pi over 6 is. Straight up is pi over 2. Straight out is pi over 4, and then we've got this pi over 6 angle right here, where let's just draw it in there. Pi over 6, pi over 6. Okay, is this angle right here. So at an angle of pi over 6, you've got a point 3 units away from the pole, and that's how you do it. And the way we determine the number of units away from the pole is we draw these concentric circles. In fact, the concentric circles, the radius of 1 would be equal to 1 unit on the XY plane. So a radius of 2, a radius of 3. The second ring would represent 2 units away. And in other words, R is 2, so a radius, this circle right here, R of 2 would be right there. And then the third ring would be right there. It's getting pretty busy right now. I understand that, but we'll clean it up down there. But anyway, at this pi/6 angle, you go 1, 2, 3 rings away from the pole, and you've got the point right there. And you can see it's in the first quadrant of the xy plane, but we don't have quadrants in terms of polar. But we do have quadrants if we relate it to the xy plane. And anyway, that point right there is 3, pi/6. Okay, so that's the first thing that you have to be able to do. And here we are 5 minutes in. Let me give you guys one. Let's go ahead and cruise on down to this first polar plane here. And let's make sure we understand what's going on here. There's the pole, always straight over to the right. Oops, that didn't turn out to be very straight. Always straight over to the right is the polar axis. Okay, just like where we measure 0 degrees, okay, or 0 radians. Okay, 0 is straight out to the right. Pi/2 is straight up. So all the angles correspond to the same angles that you've been working with around the unit circle. So everything is the same as far as angles go. Let me ask you guys to graph a couple of these on your own. Let's graph 4, I don't know, pi/4. We can even do a negative angle. Oh shoot, I did 4 again. Oh well. 4, -pi/3. And let's do one in the second quadrant. How about that? Let's go with 5, let's say 3 pi/4. Okay, so I'm starting you off with all positive r's and then angle measures. So the first thing you do is always, first you're going to do the angle. So I did a line and dot dot. So find the angle, and then the second thing you're going to do is find the r, find the radius. Okay, so let's do this one first. Pause the video and try it on your own. Okay, again, find the angle right here, pi/4, and then 4 will be 1, 2, 3, 4 units away from the pole, and that is right there, the point that corresponds to the coordinates, the polar coordinates, 4, pi/4, right there. Okay, 1, 2, 3, 4 in the direction of pi/4 angle. Okay, so hopefully you've already paused the video and you've already done these. The second one I wanted you to graph was 4, -pi/3. So again, first thing you're going to do, find the angle. First thing, find the angle. See how that A right there? First thing, A for angle. Well, A for angle, A comes first in the alphabet, so you can remember the first thing you do is find the angle. And you find the angle -pi/3. Well, you should know how to find that. Straight down is your -pi/2. And then you have 1, 2, 3, 4, 5, 6. So this has been cut into 6 equal sections. And so really the main 3 are the ones that we normally see would be -pi/6, -pi/4, and -pi/3 would be right here. So this is the angle -pi/3. Now, of course, we could call this what? What angle would this be in a positive between 0 and 2 pi? You should know that. 1, 2, 3, 4, 5 pi/3. So -pi/3 is the same angle as 5 pi/3. And so you might be wondering, well, wait a second. Couldn't I call that 4, 5 pi/3? Yes, you can. In fact, every point in the polar coordinate plane has an infinite set of coordinates. There are not, like in the xy plane, 3, 1, there's only one pair of coordinates that represents that one point, 3, 1. But in polar, we have an infinite supply of coordinates that represent each point. Well, I haven't even graphed the 4, -pi/3, but we found the angle -pi/3, and we go out 1, 2, 3, 4, and there we hit that guy right there. So that point right there is represented by, I should say, the coordinates 4, -pi/3. And the last one I wanted you to graph was 5, 3 pi/4. What's the first thing you do? You find the angle, A for angle. And so 3 pi/4, there's your pi/2, and then 3 pi/4 would be 1, 2, 3 units away, 3, I should say, lines away. This is the angle 3 pi/4. It's nice when everything's labeled, so you have to label it on your own if it's not. And then 5, the radius 5 would mean you go 5 units, or 5 well, yeah, 5 units away from the pole towards the angle 3 pi over 4. So 1, 2, 3, 4, 5. By the way, we're going to play Battleship in class on Tuesday or Wednesday, whenever you have this class. And so the better you know your polar graphing, the better you'll do in Battleship. So that's it for now. We're going to get into some negative R. What happens if it's a negative R? What happens if it's negative, negative, and so forth. So we'll get into that in the next video.